All right, and it's time for topic 4, practice test 1, Pythagorean theorem, right triangle trigonometry, basically solving right triangles. In case you don't remember, the Pythagorean theorem is a squared plus b squared equals c squared. And right triangle trig is when we're talking about SOH, CAH, TOA. When I gave you your test, I saw a lot of students just like jot this down immediately. That's great because it is not on your IB formula sheet. This needs to be in your heart. You need to have this memorized. Okay. It's not given to you on the IB sheet. This Pythagorean theorem is so important. They're like, they know that, right? You better. Pythagorean theorem is true in any right triangle. So what's really cool is that if we want to find out if something forms a right triangle, let's just take a look at which one of these is the longest. What is this approximately? Let me check. 2 rad 30 is about 10 point, it's about 11 inches. Okay, so the longest side is this 13. So we're gonna let that be C, all right? And what we're going to find out right now is, does a squared plus b squared equal c squared in this triangle? Because if it is, it's a right triangle. So let's set up 7 squared plus 2 rad 30. I'm gonna use parentheses around that because it's all that squared equals 13 squared. And then 7 squared is 49. 2 rad 30 squared, so that's gonna be 2 squared and rad 30 squared. 2 squared is 4, and then rad 30 squared, right? I keep saying rad, I guess I should say square root squared, right? Those two things cancel out, so this is just 30 equals 169 is 13 squared. So 49 plus, that'd be 120. Does that equal 169? That's 169, that's 169. Yes, those are equal. So yes, a squared plus b squared equals c squared. So this is a right triangle. Woohoo! All right. And then this one down here says find the area of each triangle. So I could break this up into this triangle and this triangle. I believe on your test it did state of the entire triangle. So that would be the whole thing. And in that case, if I want to find the area of this whole thing, oh look, I have the height because that's the perpendicular line. But this 10 is only referring to right here. And for the area of a triangle, I need 1/2 base times height. And I don't have the whole base. So I also need to find out whatever this is. And wait, no, I have the height. It's 11. Okay. So I really just need to find this missing side. So we're going to do that first before I can even touch the area. So let's find x. Well, if I look here to find this length x, I see a right triangle. And I know it works in right triangles when I have side lengths. So let's set that up. 11 squared plus x squared equals 14 squared. I know 14 is what we consider c squared because it's across from the right angle that exists here. And then I can just solve for x, simplifying my square roots. I believe this is 196. Subtracting 121 from both sides in order to cancel it out here and get x squared alone. 196 minus 121. Here, I'll move this over. Oh, that's 75. Okay. And then x squared, in order to cancel out the square, I square root both sides. Oh, no, it's just 75. Cool. And then approximately 8.66025. And it said to round my answer to the nearest 10th. So I'm going to make sure that I keep at least the 10th place is what would be the 6th place. So I'm gonna keep at least 2 more decimal places than the tenths. With this, what I have to do now is that this is that x length, right? But I need to find the area, which is 1/2 the base times the height. Well, the height's 11, but the whole base isn't just this, it's all this. So 10 plus 8.6, oh, okay. I didn't make myself enough room. Sure. In fact, I'm gonna go ahead and just do plus 10 to my answer that I just got. So that's 18.6602. Again, I don't have enough room, but that's okay, because I'm just gonna do it on my calculator times 11, and then I can divide by 2 to do times 1/2. So the area is 102 point, rounded to the nearest 10th, 6th. I don't have units, so I'm going to use UN squared to stand in for my units. And there we go. If I was grading a test here, I would want to see this Pythagorean theorem to solve for your missing side length. I'd want to see this labeled with the variable. If you're using it here, you better have it labeled here as well. And then I'd want to see at least the setup with the area here, and of course your final answer with your units. Ooh, next up we have finding the missing side. What information do I have though? Ooh, I have an angle and I have a side. If I want to find another side and I have the angle, this sounds like a job for SOHCAHTOA. From this angle, I have the opposite and I have the adjacent side. So that's opposite and adjacent is tangent. So I'm going to set up tan of 74 degrees equals opposite over adjacent. I'm going to go through the process of solving now. If I was your teacher, look, and I keep saying that, I am your teacher. I want to see all this work I'm about to do. Set up, good. But then I need to solve for x. It's in the denominator, so I'm going to multiply both sides by x to cancel out the denominator. Clearly showing my next step, I have x times tan 74 equals 13. X times tan 74, x times something, x times, let's do some division of tangent of 74 degrees. Oh, not 47, okay. Those will cancel. And then once x is alone, I grab my calculator, I do 13 divided by tan 74. What am I rounding to? Nearest 10th, gotta read that. That's 3.7, because it's 3.72, so then looking at this, I stay rounded down, so then x is approximately 3.7. And I don't have units, so I'm gonna say unit for that length of x. Okay, I should have used the approximate symbol here too. You guys have to help me get better at that. Okay. Cool. Find the measure of the indicated angle. Ooh, we have a missing angle. That's going to be a job for this thing, what we call inverse trigonometry. Okay, and what that looks like, is it gonna be sine here? Let's see. I have an angle. 20 is definitely the hypotenuse. Ooh, but 19 is the adjacent because it's touching the missing angle. So this is not a job for sine inverse. This is a job for cosine inverse. And cosine is so ca A over h. So 19 over 20. There you go. And all I have to do now is plug that into my calculator, 19 over 20. And this says to the nearest degree, so it's 18.1 degrees, but the nearest degree means that I am rounding down to 18. forget the degree symbol. That's your unit. Circle your final answer. I would want to see this set up on a quiz. I would want to see this is your final answer with your units. Okay. 2 more. Length of each arc. Oh, arc length. This is not right triangles. That's so funny. We just had to put it somewhere. Arc length is on your IB formula sheet. So if it helps you, copy down exactly what is on the IB sheet. Okay. So length, and then just plug in what you know. If I'm looking for this thicker line, I'm using 315 as my theta over 360 times 2 pi. Do I have my radius? Yeah, 14. And then you could plug that all into your calculator. The only thing I might recommend is you might want to put parentheses around this depending on your calculator if you'll like that or not. And use your pi button. Nearest tenth. So I got 76.9690, et cetera. Oh, and I keep forgetting to use the squiggle. Okay. 76.0. The nearest tens place is the 9. So this 6 makes me round up, but that really makes me round up the next place value. So it'll be 77.0 to show that accuracy there. And do I have units? Meters. Arc length, so this is meters. The work I would want you to show is the setup here at least, and then the final answer with your units. And then last but not least, a 20-foot ladder rests against a wall. Here's a wall. Here's a ladder. The ladder is 20 feet. The base of the ladder, base is the bottom of the ladder, is 7 feet away from the wall. I'm going to assume we're making a 90-degree angle at this wall and ground here. Ooh, what angle does the ladder make with the ground? With the ground, angle right here. This seems like a job for, this is funny. Look, hypotenuse and adjacent again. That's just like a number 4. Cosine inverse of adjacent over hypotenuse. Cosine 7 over 20. And it didn't say to round to anything, so I'll keep 3 sig figs. And as your grader, I would want to see the picture setup and the setup of the equation, what you type in your calculator, as well as the final answer. Whew. All right. Under topic 4, the biggest misconceptions I saw were just people using the wrong trig function, mixing up which goes on top, adjacent over hypotenuse, or whatever you might have, people mixing up, oh, is it 13 over x or x over 13, right? You gotta know that order. So katoa. People also solved incorrectly. If your x is on bottom, you're multiplying by x and then dividing away, okay? Versus if you have the number on bottom, you just have to multiply both sides by that number. Please make sure you are following the algebra that is necessary to go. Set it up and then go through your algebraic steps to get through your answer. If you're asked for the area of the whole triangle, consider what missing pieces you have or that you need to find in order to find the whole height and the whole base. You may need to use things like SOHCAHTOA or Pythagorean theorem to find missing pieces before you're ready to find the area. And then on arc length, honestly, we did mostly well. The only people who really got it wrong were the people who, 1, didn't try it, or 2, they were silly heads. They ended up writing down the area of a sector, okay? Length of an arc, you're finding part of the circumference. Not part of the area, part of the circumference. So write it down exactly as it is. on the IB formula sheet. And you'll be good to go. That's all. Hope you had a fun time. I know I did. Bye.